One of the big challenges in research is the government and industry pays a tremendous amount of time and energy to do studies on various scientific disciplines. And the results of these studies are thousands of papers written, tens of thousands, millions. Is there a way that I can get computers or supercomputers to start to look through all this information and quickly help us find, for a disease like COVID-19, what do we know so far and what are the potential connections that we can find? Here's what's not known, and this may be a promising research direction to go forward. So that was our motivation for the SNAPSHOT project. And that's where we were going for, is to say how to do that. Now that involved two major challenges. One is to say how to pull all the information out of the documents, which involved a lot of new research, a lot of new ideas. And then secondly, how do I take that huge graph of information and how do I find the paths? How do I find the sort of the discovery in those connections? And that required significant advancements in high performance computing.
This belongs to a discipline in artificial intelligence called natural language processing. It involves understanding the text that has gone into this publication documents and trying to establish the connection among them. In this case, the blue dot is a medical concept the user of the tool is searching for. The small round dots are the other medical concepts in which these are related, and the lines that connect these dots are the papers that relates them in some way.
The power of SNAPSHOT is then when we look at the connections or the concepts that have very short paths between them. And we found and we were able to verify that when the path between two concepts, even if they are not directly connected, but they have a very, very short path, that very often indicates that in the future they should be connected.
We took like almost 4 million papers and the medical concepts within these papers, and we tried to connect all of them. And that we could do on 4096 summit nodes in 21.3 minutes. To give an analogy of how big is this computation, let us assume you give every human in the world a calculator in his hand and ask him to perform one multiplication for every second. Whatever the entire calculation, the entire population can do in 7.5 months can be performed on Summit in just a second.
Really, the scale of the problem has been a big complication. And so this is really where I think SNAPSHOT stands out, in that we've been able to process a much larger amount of data than we even expected ourselves we would be able to. And we really were able to process basically the entirety of biomedical literature with this.
In this case, we used two standard techniques called matrix multiplication that has been explored in HPC for quite some time. And the nature of communication is called a collective communication. It's a beautiful way that classical techniques that have been investigated for a few decades in high performance computing, how that came to use when the world is faced with the pandemic like COVID-19.
I think it's exciting in the COVID area, but I think this can go well beyond that into really any scientific area. So our big challenge now is to say, all right, how do I take what's already been discovered and then predict where the next big discovery will come? And that's what we're spending a lot of time and energy on.
We're not sure for the data that we're predicting right now what is actually going to in the future turn out to be a real connection. And it's very possible that a lot of them are. And so this is where we're working with biomedical scientists and doctors who are helping us understand whether these things that we maybe don't know as of right now actually are really valid and should be investigated further.
What we'd love to have is we'd love to be able to say, can we have this software available? Can a community of people start to work and develop it like what you see typically in an open source kind of community? And we'd welcome that. We'd love to see this get in the hands of some of the top scientists to see how to make major breakthroughs.